when we're coding. And by guessing, I'm talking about that thing we do where we propose a solution without understanding the problem. And the upside is if it works, the problem is solved. Like I didn't have to think about it much. I just shoot out the solution, boom, we're done. The downside is that if it worked, I can't explain why it worked. And also, if it doesn't work, I'm no closer to the solution. I just have to shoot out try something else, and we're just guessing. I found that we guess at work usually because we're responsible. It's a sense of duty or professionalism. We want to make good use of our employer's time, and learning can sometimes feel like a self-indulgent activity, but I'm here to work. And because of that sense of responsibility or professionalism, we choose to just try something and race to the solution because we need to get solving. I've seen two extremes of this. My coworker, Kevin, who gave me permission to say this, he's a couple years into his career. He's energetic and curious, and it's not uncommon as we're working that we will hit some technology or tool or practice that he hasn't seen before because he's only been at it a couple years. And so I might recommend that we take an hour, go watch a video or read some docs or do something to learn, and then come back to the work. And his initial reaction to this was surprise, saying, like, we can do that in the middle of our workday? Is that appropriate? Like, is that really a thing? That's the one extreme. The other extreme is a fellow named Rob, who I worked with early in my career. And when we first started working together, he'd probably been programming longer than I'd been alive. He had lots of experience, lots of wisdom. And the two of us were working on a project. It was AngularJS. It was a while back, and we're integrating with some backend system. And he knew a lot about the backend system. He'd built some desktop applications for it and other pieces. And I'd done some web development stuff before. And the two of us were teamed up. We had our client meeting. We made the plan. And after kind of doing the initial work, the first day we made a plan, he tells me he's bought a couple textbooks. He'll see me in a week. He didn't know much about the website development. He said, I need to know this to do well. And then he just left with his textbooks and studied. And when he came back, he was much more like he knew what he was doing. And I was so surprised as this young programmer to see this veteran just off he goes. Bye. And so there's this stark contrast from me talking to Rob and my coworker Kevin being like, we can learn at work. And this tenured developer saying, I'm out. I've got my textbooks. See you later. So my hope for our time together at lunch here is to convince you to feel comfortable saying, I'm going to take the time I need to learn what I need to know to do my job well. And also to give you some more tools for doing that type of learning. So if you're already there, if you're already keen to take the time you need to learn while you're at work, it'll still be interesting because we're talking about some of the ways that we can do that well. And that's why I called it How to Become an Expert When You're on the Clock, because we're talking about ways to learn at work. I think the starting point here is developing a love for the problem. It's really easy to get excited about the solutioning phase, but we jump to the solutions before understanding the problem, and it's more effective to love the problem and really understand the problem before we get to the solution. The more we know about the problem, the more obvious the solution. And we can get into a state of compounding learning, a positive feedback loop, where because we see similar problems in the future, the learning we do now helps us with today's job, and it also helps us next week and next month. And so we've got like a compounding interest of learning that helps us be more and more effective over time as we see similar problems. So instead of guessing, I suggest we learn, and we'll talk about a couple ways to learn when we're at work. As we're learning, it can be tempting to go for cheat sheets, like the tell me what to do. When I see X, what do I do? Some of you will maybe remember printing off your MapQuest directions when you're driving somewhere. You get your ream of papers with turn-by-turn directions for how to get from your house to the restaurant. And this works great as long as you're en route. But if you get off route or there's construction and you can't follow the path, it's not that helpful because it only gives you suggestions on that route. And when we have cheat sheets or rules of thumb, they're really useful if they directly apply to what we're doing. But as soon as something goes sideways and we're surprised, then they don't provide so much value. The alternative is the map, the lay of the land. might be familiar with this, I don't know, it's a folklore legend of the engineer fixing the boiler with his hammer. There's an important boiler in some factory, and it had broken down. The engineer who maintained it for his whole career had retired. And they brought in several professionals to try and fix it. They did all sorts of different things. They couldn't fix the boiler. The factory shut down. It's an emergency. They managed to pull the retired engineer out of his retirement to come fix it. And he looks at the boiler and listens and pokes around and pulls out a small hammer and taps something and then turns it on. Boom, it comes to life. It's working. And he sends them an invoice, $10,000, which was a bit surprising for them because he only hit it with a hammer. So they said, could you please give us an itemized invoice? So we revised the invoice and sent it back. 2 line items. The first one, hitting the boiler with a hammer, $1. Knowing where to hit it, $9,999. And of course, the point is he spent decades intimately learning about this boiler, and that expertise is very valuable. They couldn't find anyone to fix this because it's a quirky old boiler, but because of the mental model he had of the boiler, just hearing some things, looking at it, just took him a little bit of time to know exactly where to tap. And you've probably experienced this or seen other people do this, where you get a stack trace, an error message, and it's nonsense. Like, it doesn't tell you anything. But someone who really knows the language well or the framework you're working with, they glance at that and go, oh yeah, you need to twiddle the what's it, and then it'll all work. And the suggestion has nothing to do with a text printed on the screen, but because they know the system so well, it's just like that, like the engineer with the hammer, they know exactly where to hit. And what I want as they get better as a programmer, and I think what a lot of us want, are to have a big impact with a little bit of effort. And the rules of thumb don't help us so much for that, but the mental model, like having a clear understanding of the lay of the land, lets us have a big impact with little actions, just like that legendary retired engineer with his tiny hammer. So let's talk about some techniques for learning mental models. One of my favorites, read and forget. You choose some high quality documentation, a published API doc or a textbook or something, and you skim read it. All of the stuff that's relevant. So that maybe not the whole textbook, but there's a chapter that's relevant, or a single entry on Mozilla Developer Network or something. You skim read it. If you need the whole textbook, sometimes you can just skim read the table of contents to get the gist. And then you forget it. You don't have to remember the details. Because as you work and you hit problems, the problems remind you of something that you read, and then you go look them up. So we're not trying to memorize the textbook. We're trying to get a lay of the land to know what's there. This rough mental model will help us navigate problems as they come up. It's that map of the territory, a sense of what's possible. You want to know what you don't know. So my teammates and I hit this last week. We had a bug in our code where when you hit the browser back button, things went sideways. And so we were writing a unit test to cover the scenario, and this thing we're working on is in Angular, and the unit tests run in a browser. So we could use the actual browser back functionality to get this really realistic unit test. So we looked up how do you make the browser go back in JavaScript? And apparently it's this back method, history back. So we looked up the first hit on our web search, the Mozilla Developer Network. Here's what we saw. The back method of the history interface causes the browser to move back one page. Yes, this is what we need. But we kept reading, read it all. It has the same effect of calling history go -1. If there's no previous page, the method call does nothing. It's asynchronous. We can add a listener to pop state to determine when the navigation is completed. So just as a matter of course, we read the whole thing. But really, once we hit the first line, we knew we'd found the right thing. So we wrote our test. We ran it, and nothing happened. We were sure we were calling the interface correctly. There's no arguments. You just call history back, but the thing wasn't happening. And then we remembered, if there's no previous page, it's a no-op. It does nothing. So we updated our test to have just a silly, like, navigate somewhere and then run the test. And then it did the thing. And then we ran the test again, and it didn't do the thing. And we ran it a couple times, and like sometimes it worked and sometimes it didn't. And we're like, it feels like there's a race condition or something. And we said, wait, it's asynchronous. Pull up the docs. And we pulled it up. It's asynchronous. Add a listener for pop state in order to determine when the navigation is completed. So we added a listener for the pop state to determine when the navigation is completed. Before we called history back, we put a listener for pop state events. Then we call history back. And then as soon as we get our first pop state event, we continue with our test. And then it worked every single time. And it was so cool that because we read those extra 2 paragraphs, at the beginning we said, we don't need to read those. All we need to know is this the right API? It was. But we skim read the whole thing and forgot most of it. But as the problems came up, they reminded us of that thing that we'd skim read. And so we could proceed with confidence. And we ripped through that test, which it would have been such painful troubleshooting to figure out why is this not working. But because we'd skim read it, we're like, oh, ready to go. We had that mental model. All right, so technique 1, skim read, forget a bunch, but you'll remember it when the problems come up. The next one, ask someone else for their mental model. Folks who've been working with a particular technology for a while, they've got the lay of the land. They can turn those cryptic stack traces into, I know exactly what to do. And if you can draw that mental model out of them, you can benefit from all their experience without having to go through all those pain points. So we did this year. We worked with Terraform for infrastructure as code. And one of my teammates hadn't used it much. So they could get by, but it felt like magic for them. And so we took 30 to 60 minutes at a whiteboard. We discussed infrastructure as code. And our prompt for the discussion was, hey, if we didn't have Terraform or any of the other off-the-shelf alternatives, if we didn't have Terraform, what would we do? We talked about version-controlled bash scripts and where we would store state, like our resource IDs, and what happens if 2 people change state at the same time. And so those of us who were familiar with Terraform, we're talking through some of the problems that you face if you're not using something for your infrastructure as code, something like Terraform. And we talked through what are the problems we would face. And by the end of the conversation, my teammate's mental model went from Terraform is for AWS to Terraform is a wrapper around AWS APIs. And that is just a tiny change, but it really helped them from this is just a magic thing we do when I need to go to AWS to the Terraform resource maps to an AWS API, which means I can look at AWS API docs to understand this Terraform resource and what all the inputs do. And it didn't feel like magic so more. So it didn't take us long, but we were able to transfer our mental model to that teammate so that it wasn't magic. So here's some ideas of how you might ask a teammate. Hey, Peter, we can't wrap our heads around Terraform. What is it? Do you have an hour to whiteboard with us? Or, hey, Sharon, I'm trying to understand what Terraform is for. If we didn't use Terraform, what would we do? Do you have some time to help me out? Or, hey, Dexter, I've seen you doing a lot of Terraform work. We just wrote some Terraform code, and I don't really get what it's doing. Can you help me out? And so the idea here is to figure out how this expert thinks about the problem. So you're not asking what code should I write? You're asking like, how do you conceive of this? What's your mental model? Draw me a map, a picture, so that we can navigate new problems well. There is a prerequisite here where it has to be safe to say, I don't know, can you help me? And so you got to ask a teammate where you're safe asking that question. And hopefully there's some people in your workplace who you can say, I don't know to. It's a lot harder to learn together if you can't do that. But even if you don't have close coworkers, maybe you have other people in your network who you can ask. So just calling out that this only works if you've got that level of psychological safety. All right, skim reading, asking others, and then play. So sometimes the fastest way to solve a problem is just to goof off, which means you're busy, but you're not producing something useful. The useful part is what you learn. And if you think about kids playing with blocks or toys, they're developing this mental model for how physics work and how they're learning all sorts of things, but they're not producing anything. They're just goofing off. But as a result, they've got a better model of how the world works. So for us, that might mean code exercises or a toy project. I'm going to build a little thing that I want for my own personal use. It's just to practice, or maybe you want to try lots of different ways to do the same thing. You're doing work, but you're not producing something valuable. The trouble there is there's maybe some optics problems, like won't I get in trouble if I'm goofing off? So the way I conceive of this is if I don't know what I'm doing, I'm going to have to make some guesses. I'm going to try something. Is it going to work? Oh, it didn't work. Okay, I can try something else. And I'm going to go through all these different things I try. And that's going to take some time. So the time I was going to spend trial and erroring until I finally hit on something, I'm going to spend all that time learning. And then when I go to the problem, it goes really quick. And my teammates and I have experienced this when we're using a library or technology that we're not familiar with. Sometimes we just spin our wheels. Like you twiddle a thing, oh, it didn't work. Can we try this? No, that didn't work. Delete it all. Try this other approach. No, that didn't work. Let's tweak it. And we're just spinning and spinning. And what we've started doing is instead we close our main project. We've got another code project that's just unit tests for practicing. And we practice that API. We'll set each other puzzles and see who, like, try to solve them quickly. We'll spend sometimes 2 hours solving these puzzles. Then we come back to the production code, and it's like we've learned a new language. Instead of guessing, we're proceeding with this like confidence to just, I just wrote out the solution, and it's really exciting. So instead of guessing, we learn, and then we quickly solve the problem. So that's how I rationalize it, but that maybe doesn't help with how we talk about it. So my short answer is don't say the word play, because play isn't part of our business vocabulary. It doesn't fit. There's no word play in our business vocabulary. But there are lots of professional and technical descriptions for what we do when I'm talking about playing. So I say play because I think it's a good description of it, but I wouldn't use play to report this activity. Here are some examples of what I might say. We're building a prototype. We are exploring the capabilities of our dependency so we can integrate it with more effectively. We're doing a trial run of our integration in a sandbox so we can more quickly pinpoint the problems. We're doing assumption testing on this third-party component. Or maybe it's a really time-based thing. Hey, the last few times we used X, we went a day over budget. We're spending 4 hours. So we've decided we're going to spend 4 hours to find ways to reduce our uncertainty around X so we can reduce the chance of repeating the overage. And then we're going to measure our next use of X to see if we're still exceeding our estimate. All of these are ways of saying, I don't know what I'm doing. I need to go learn. I'm going to go do some work without producing useful output. The useful result will be that I'll know more, and then we'll proceed well. And so you can figure out how to express this part well. And so I'm highlighting this as an important step to the learning, because if we can't communicate clearly about what we're doing, we're not going to have the freedom and budget to do it. So even though learning can be more efficient, it's maybe not obvious to my boss or my stakeholders that learning is more efficient than just powering through. Because the fact is, trial and error makes me look busy. It looks like I'm working hard. So if I just trial and error my way through it, it looks like I'm really engaged, like what a diligent employee. Whereas if I stopped and I was reading or I was doing a toy problem, that's not impressive, and it might look bad. So I'd suggest you can identify the business alert specific. I've got a network info concern. Am I still coming through okay?
You blipped, but you're back, so I think we're good.
All right, carry on. The business drivers, so specific to your business context, what's the thing that makes learning worthwhile? And then you can report your learning in the context of that business driver. So for example, if your business values predictable delivery, like if you're going to do something in a couple days, it turns out it's much longer because you were surprised. If your stakeholders aren't pleased with that, you can frame your learning time as work done to reduce your variability. You can point to recent times where you had some unexpected delay or a surprise, and you're saying, hey, we're going to invest in our learning so that we don't have those sorts of surprises. It's worth calling out, there are business situations where we want to take risks. So it's not safe to assume that our stakeholders want you to reduce risk as much as possible. So it's not like we just say, learning reduces risk, so we got to learn. Because sometimes they say, take more risk, like we want just the chance of going faster. So we need to understand what's the actual business context we're working in. The other angle here is it might be, maybe your business has a good stomach for variability. Like we're doing research and development, we get it. It just, some things take longer, that's how it is. But in the future, we want to be able to move faster. And we want to know what can we do to deliver faster. And then you can report your learning in terms of that investment. This is something I can do now so that every time we use this technology or this platform, this tool, we can move faster. There's also times where the future has nothing to do with it. Like this week, for me to do my task, it will be faster if I know what I'm doing. And that's the example with my coworker, Rob. It wasn't like we were going to be on this project for years and years and he's thinking to the future. Like we had a fixed scope. It was a contracting thing. Like it was a very set amount of time. And within that context of we've got a couple months of work to do, he said, I need to spend a week on this so that my next 2 months are more efficient. So sometimes it's just, hey, to get through this week of work, I need to take some time learning. And then you don't need to link it to any business value. You just say, I got to get the job done, which means I got to know what I'm doing. And if someone says, what if you didn't learn? You say, well, I could take longer and not learn. And you're just reporting the learning makes me go faster. However you do it, you got to figure out how to report your learning time well. If it's good for the business, your leaders should be happy you're doing it. But if you can't explain why it's good for the business, they're not going to be happy you're doing it. So figure out how to explain that it's good for the business. Everyone's happy. Okay. Instead of guessing, we're going to learn. We're learning mental models. We might skim read, ask others, play, or do other things to develop that mental model. And as we're doing that, we're going to figure out how to report it well. We're going to shift gears here. We're going to go to a live coding example. I say live coding, I've prepared the commits in advance. We're going to be stepping through some commits and running some code together. It's a contrived example. I'm pretending that I'm not very familiar with unit testing. It's kind of a dramatic reenactment of some real learning that I've done in the past. So I'll pretend there's stuff that I don't know when in fact I do know it. This scenario is fake, but I'm trying to describe to you something that I've really experienced and I know other people have experienced. So play along with me. We're going to pretend that that I'm really puzzled by the things that I say I'm puzzled with.
So, Alec, we've got one person put a question in the Q&A, and actually Cliff also said that he just this last week fixed, I think, a boiler by hitting it with a screwdriver. So like he's like, that's not a contrived example, that actually happened. But then when I tried to ask what type of thing he hit it with, somebody told me he'd charge me $20,000 to find out. So Christopher was asking about LLMs, if they short circuit the mental model needed to solve problems. I thought it was an interesting question.
Mm-hmm. Yeah, maybe they will. I haven't found that they do. And in fact, I found when I have when I don't have a clear mental model, it's hard to use LLMs well. But when I have a crystal clear mental model, then I can get a lot of leverage from them because I know the sorts of things I'm asking for. Even if I don't know the syntax for it, I don't know the details, I've got the lay of the land. And the metaphor there might be if you've got like you're trying to get from point A to B and there's some mountains and there's some rivers. If you've got the sense of I'm traversing mountainous terrain, I'm gonna have to go over some rivers and some mountains, but you know don't know the details, you'll be able to ask much better questions of a local guide than if you thought you were in a desert. And so for me, the mental model helps us to make better use of it. But I don't know. It might be something that I don't know. I haven't found that, but I'm open to be surprised, and maybe someone else has experienced other things. So I'm not speaking with authority here, but in my experience, the mental model is maybe all the more important in light of the LLM and helps us get more leverage.
Let me see real quick if there's any other questions before we get into some code. Looks like we're okay. Looks like we're on track. Okay, code.
All right. Let's pull up. I'm sharing my IDE. Is that coming through here?
Looks good.
Beauty. All right. So here's my my imaginary mental model, and I'm gonna just say I'm gonna talk as if it's true, but you know, for the time that we're doing the coding, I'm pretending. So the things where I say I think this, I'm pretending to think this. All right. Mental model. We use Jest for unit testing at work. It's a JavaScript unit testing library. Even if you've never seen JavaScript or Jest before, it's a unit testing library. It maps to whatever your mental model is for unit testing library. All right, so at work we use Jest for unit testing, but at home I prefer to just use console log. The print statements are all I need to check my work. And my mental model is like I can explain how and why to use print statements to check my work. I also am familiar with the syntax for Jest because I have to use it at work, but it feels sort of like magic and unnecessary magic. The print statements are good enough for me. So my goal here is I want to connect my familiar print statements and the techniques that I'm used to using with the syntax of Jest. Because currently at work, I'm frustrated that we have to use Jest when print statements are good enough, and I want to maybe resolve that frustration. I also want Jest to feel less magic. I want it to feel familiar because I've been using print statements for a while. I'm used to that technique. So I'm going to be solving FizzBuzz as is practice. For those who aren't familiar, it's a little coding exercise where we're converting a number to a string. Most numbers are just the number as a string, but if it's a multiple of 3, we're returning fizz. If it's a multiple of 5, we return buzz. If it's a multiple of both, we return fizz buzz. And actually for this, I'm not even going to bother stringing the numbers. I'll just print them as a number for the sake of the exercise. And my learning plan here is to solve FizzBuzz the way I want to with console log. That'll be fine. And then I'm going to transform my console log to adjust syntax and see what I learn from that. And as I go, I'll adjust my mental model. So you'll be seeing me jump over to the mental model.markdown, where I'll be updating kind of my notes of how my mental model changes while I'm working. So let's get some, we've got an empty FizzBuzz function, and I've got fizzbuzz.spec. This module.js, MJS, and I'll run this here, and it's printing out undefined. So I'm going to be doing test-driven development as we go. I'll do one example at a time and build up some examples as we go. But this is not that useful because undefined doesn't tell me what it's supposed to be. So I'm going to update this to print out what I expect. If I'm passing in 1, I want to get 1 out. We're calling fizzbuzz1. It should be 1. I call it, it's actually undefined. So let's fix it. FizzBuzz returns 1. Check. We're passing. All right, let's continue. How about 2? For 2, it's still returning 1 because it just hard-coded the 1. And again, I'm not jumping right to the solution. I'm doing one example at a time because I want to write out a test for each of my examples. Again, contrived example. We're pretending that I don't like unit test frameworks, but I love TDD. Just roll with it. That's our scenario. We've got, they're always return 1. Let's make this pass. Now we just return the number itself. So expected 1 got 1, expected 2 got 2. We're in good shape. Now we'll move on to our first really interesting test. Pass in 3, we get fizz back. And actually we got 3. So let's go back to our code and implement that. We'll say, if it's 3, return fizz. Again, we're starting with just these naive implementations while we're building up our set of examples. Expected 4, got 4, that still passes. Let's do 5. That's going to be another if statement. We want to, if it's 5, return buzz. There we go. That's passing. And continue down numbers. Let's do 6. That one, expected fizz got 6. So expected fizz got 6, and that's because we just said equal 3. So it's getting marginally more interesting here. Let's change it from equals 3 to divisible by 3. So now if the number is divisible by 3, then we're going to return fizz, and yes, it is passing. So that was our 6. We probably need to do the same thing here. So we need something that's divisible by 5, but isn't 5. Let's do 10 next. So expect 10 to be buzz, but it's still 10 because we're doing the equality. So let's go and make that same divisible by change here. And we're good. And now the next one, maybe the most interesting one, is divisible by 3 and 5. So let's look at our 15. And we expect it to be fizz buzz, but we just got fizz because it's matching, I guess, that first if statement. So I'm going to make probably a bigger change here, and then we'll make sure that it still passes all of them. So we want something, if it's divisible by both of these, we're going to return, we're going to combine it together, otherwise we return the number. And I'm going to do that by building up a result string. If it's divisible by 3, add fizz. If it's divisible by 5, add buzz. And if there's any result, return it. Otherwise, we return the number. And let's do that. Okay. For 1, we get 1. Check. For 2, we get 2. Check. Fizz to fizz, 4 to 4, buzz to buzz, fizz to fizz, buzz to buzz, fizz buzz, fizz buzz. Done. There we go. That's our implementation. Here's our beautiful test file with a bunch of print statements and our implementation. So the learning plan here was to solve FizzBuzz using console log, and then then transform it to use jest like syntax. But I want to go and make some notes first. So let's update the mental model. With console log, it was helpful to write out the expected value. My first console log, it just printed undefined, which was less helpful. I wanted to say, what do I expect and what did I actually get? Because then I could compare. Like when I did that big update for 15, I wanted to be able to compare all of them. So that was useful. Also, it was enough. I could do TDD for FizzBuzz. The print statement did just fine. But also, at work, when we use the unit test runner, it says pass or fail. But for me, I had to go through each line and compare expected to actual. So it would be really nice if I didn't have to go check those things. So from a test runner, I want it to be easy to write expected and actual, and I want it to tell me if it passes or fails. So the next step, I think I'm going to introduce a bug and see how well my console log does. And so this is where we're talking about the playing. Like I've come up with this test scenario and I go, well, what would it do if there was a bug? And we're just twiddling some stuff. See what happens. All right. Instead of equal 0, we've said equal 1. It's going to break some stuff. 1 is broken. That doesn't match. This doesn't match. This doesn't match. We've broken some stuff. But again, I have to go through every line and check. I think the thing that's bugging me most is that I can't check. So the part I want to do next is make it so that it tells me if it still works. I don't like that I have to keep checking every example to see if it matches. I just want it to say pass or fail. So my plan was to shift towards the jest syntax and see what I could learn from that. So we'll go to my test, and I've introduced this test method, and I want it to check for me if expected and actual match. So I've passed an expected and actual as an input. Expected 1, actual is whatever we get back from FizzBuzz 1. And this is almost the same as before. The console log, let's print it out. Expected 1 got buzz. So before I had this thing that was showing the input and then going to the output, and it was nice to be able to see what the input was. But the key thing here, we've got our expected, we've got our actual. So this is refactoring. It does the same thing or close enough. So I'm going to go and use this test method for all of my examples. And aside from no longer showing the inputs, that does the trick. That'll give me the feedback I need. So now inside that test, I can get my pass indicator. So if expected equals actual, then I can print out an appropriate emoji. There we go. So the ones that pass, we've got our green, we've got red for the ones that don't. So this is an improvement. I don't have to go and look at each one. I can just scan. If it's red, it fails. And now, yeah, that's a help. I'm going to go and make the adjustments to my mental model. Tells me if it passes or fails. It's nice that it tells me for each of these, but also I'm used to seeing at work, we have a pass fail for the whole thing. Like at the bottom, it says if it passed or failed. And it would be nice to get that going as well. So I'm just going to update the spec to keep track of how many failures there are. If it didn't pass, it was a failure. At the end, if there were no failures, we passed. Otherwise, we'll print out the failure count. So that was a small change, but that's much more useful. And we can now just get the test to pass. So I've went and fixed that bug. We'll run this, all pass. Beautiful. So each example, I've got my nice green check mark. And then at the end, we've got the all pass. This is helping me to get that just at a glance. What do I need? When I'm thinking now about how I write them, and in jest, we have expect X to equal Y. Whereas in our test right now, we've got this, just says test. The IDE helps a bit. It says expected because my variable is called expected. So we've got expected 1, but my plan was to try to make this look like jest and see if that helped somehow. So I think we'll maybe try with the expect syntax. The other thing I'm noticing is at work, when we do our jest tests, we just have our example code, but here we've got this test infrastructure that's just mixed in with my test, and we've got this down here, and it would be nice if the test file just had the examples. So these are, I'm kind of comparing what the familiar syntax from work with what I'm seeing here, and I'm going to try to shift a bit towards more what we see at work and see what I learned from that. So here's how we would write the expect to equal at work. Obviously, there's no expect, the method's undefined. So now I'm gonna just make a method expect, and that fixed that one, but now, there's no method to equal on undefined because expect doesn't return anything. So I can make this return a thing. So then we won't get the cannot read properties of undefined, but they're still not to equal because this thing doesn't have a to equal. So I can make an empty to equal, and now the compiler errors are good. We'll run it. We lost our test number 1. It's not doing anything. This is empty, but the syntax worked. It ran. And now I've got my expected and actual, so I can call my familiar test method, and I've got the stuff. So before we had test, we had 2 of them. Now we've got expect this to equal that. I'll roll with it. I'm trying to make it look like jest. So let's use this for all of them. There we go. So this is all right. We run it. It's still going. We still have all of this test junk that's messing with the examples. So we need a place to put it. In jest, the tests are all wrapped with the describe block. So maybe if we wrapped everything in a describe block, kind of an outer thing for the test, we'd have a place to put our stuff. So let's try that. So again, we call describe. There's no such thing as describe. We just imagined it, and it's blowing up. There's no describe. But we can make a method describe to make the compiler error go away. But it's not running anything. So we just need to run the callback. So I got the syntax here from just copying what we do at work with jest. And I guess I just need to run the callback, and our tests still go. So this is an improvement. I can now put all the test setup stuff inside of the describe, and it would be hidden away. Except expect is undefined because expect is now inside of the describe thing, so we don't have it out here. But in jest, expect and describe, they're not imported. They're globals. So maybe we just make expect a global, and then it works. Let me run this. It feels wrong to make a global and just leave it lying around, so I'll remove that afterwards. Okay, and now let's hide it away. Put it in a folder or a separate file, DIY unit. And so this is the same stuff as before. We got 24 lines for our test file. And this, I mean, in jest, everything would be wrapped in an it, like you'd have test names for all of these, but it's not bad for 24 lines. Let's update my mental model. My bare minimum test runner, I want it to be easy to write a list of examples. I don't want my test infrastructure cluttering up my examples. It runs the examples. It tells me if any fail. It gives me this overall pass or fail, so I know at a glance if we're all good. Yeah, it's not bad. I'm thinking about how it organizes examples. And it kind of makes sense why I don't feel the need for it when I'm on my hobby projects, because I don't have that many examples to organize. But at work, we've got big systems with lots of examples. So of course you need an example organizer. That kind of fits. And I wanted to summarize the failures. I did not like having to go through every line and make sure that it matched. I really like that it just says we're all good to go. And also, I just went with the jest syntax because I use that at work. I don't know if there's better syntaxes for test running or whatever, but I just went with what I had. All right, so let's take a look at what we've got. We have this 25 line. We've got to describe. We count our failures. Every test we run, we check if it passed by doing a comparison. We log something out. We've got this expect function to give us that expect syntax. There's some global variables. We run the tests, and then we log the summary. FizzBuzz is unchanged. It's our little FizzBuzz implementation, and our spec is a bunch of examples. All right. Let's get back to our slides and kind of regroup. we did this exercise, and then we can turn our play into some learning by reflecting. Like, what did we just do there? And so after the playing, I find it helpful to use the word just to do this reflection. Just invites us to overlook details, which usually we don't want. If I say, oh, just fix the thing, it tells me I've probably missed something. But if we're summarizing, we actually want to overlook something. So again, we'll talk a bit about how to summarize, and then I'm going to do a summary of the coding that we just did. So I've got a couple of theoretical slides about just, and then we'll talk about what just happened with our coding. We're trying to refine our mental model. You've maybe heard these quotes. The map is not the territory, but the territory doesn't fit in my pocket. Every model is wrong, but some are useful. So we have on the right a topographic map of a couple mountains with a river running through it. And I am certain that today, the exact shape of that river does not match the shape it was when this was mapped. And there are nuances to the shapes of the mountains that are incorrect here. But if you had a fully precise map, it would fill your entire 50-liter backpack, and you could not go your adventuring. What we need is something that's the right level of abstraction. So just is really helpful in updating our mental models because we want a high-level map. We don't want all the details. So I want something. When I use just, I'm saying something that's technically wrong. Like it's oversimplifying, but it fits in my brain well. And that's what I want. I want something that's useful and just like less wrong than before. So we did the unit testing exercise thingy. Here's some conclusions. Unit test suite is just a collection of examples. Unit test assertion, it's just a comparison and a print statement. Unit test runner is just a program that tells me if my code matches all my examples. So I have now these false but useful statements. They're not technically correct, but it's a helpful mental model. I've got this simplifying thing, and I was able to bridge from my console log preference to what I was doing at work. So it turns out console log and expect to equal are pretty similar in effect. It's just that expect to equal, it also has that conditional, and it might give a check mark or an X. So there's a bit of extra comparison, but it's kind of doing the same thing. So now it doesn't feel so magical to me. I also have this fresh insight on how to write tests. I'm writing a collection of examples. I'm thinking about this as a collection of examples. And so that might help me knowing which test do I write next? Well, which do I want to add to my collection? And then I also have a better appreciation for the test framework. It gives me the single yes or no. So I'm not going to be so grumpy that we have to use just at work because it's nice that I don't have to check every single console log. And again, this was a contrived example. I knew these things before I started. I set out, so it's a bit contrived, but these are the sorts of insights that I have gained from doing toy projects, and I've seen other people as well. And so the reason that we went through that whole thing was not to go, aha, this proves that if you just did that exercise, you would learn all these same things. Like I can't say what you would learn from doing these exercises, but what I have found is when I do these sorts of learning, just let my curiosity go, oh, what if I broke the test? Would it show me nice things? Oh, I'm getting bored of checking all these things, and just taking some time to play around and pay attention to what I like, what I don't like, making some notes as I go and reflecting afterwards, especially using those just statements to come up with some oversimplification that I can store in my brain. It helps me to have a lot more confidence in what I'm doing. And the next step for me, if I really was someone who didn't like jest and preferred console logs and was exploring this, I've now got the sense of it summarizes my outputs. Expect to equal is just a print statement. If I go to the jest law documentation now, or if I look at a video of what is jest, I'm going to have some things I'm looking for. Like, how does this help me summarize my tests? How does this help me organize my examples? And because I've got an appreciation of some of these capabilities for jest, I can now go do some more learning. And before I was just grumpy. Why do I have to use jest? Print statement is better. Now I'm like, okay, well, I like that it summarizes the output. I like that it runs my code. And so I've got some more questions I can now take to documentation or a video or something like that, because I've got this better lay of the land. And that's like, if you've got a map of the territory, there's some mountains, there's some rivers, you go, there's a waterfall. Where's the waterfall? Let's go find the waterfall. And you can go look for it. So I've got this sense the waterfall here is, I don't have to read all the console logs. it like summarizes it. I want to know how you can use Jest to summarize the pass-fail state of my whole application. And I'm going to go search for that thing. I haven't seen the details of it, but I've just got a sense of it. All right, let's summarize some of the things we've talked about. Often we skip learning because of our sense of professionalism, because we've got the sense, I need to stay on task. But as a professional, I think it's more important that we do good work than that we look good. And so, in my view, it's a mark of professionalism to say, I don't know, and I'm going to take some time to learn. And as we learn, we're focusing on learning that mental model, the lay of the land, rather than the rules of thumb, so we can adapt to surprises, to new scenarios. So builders, you can put this into practice by not seeking permission to take the fastest route. If learning is the fastest route, go do it. But if you're feeling pressure not to stop and learn, practice reporting the business value of learning. If it's good for the business, then there should be a way to report it so that your stakeholders and managers are pleased that you're taking this time. And some ideas again for building the mental model: skim reading the docs, asking for advice, playing in a sandbox. Let me go back to that one. Skim reading the docs, asking for advice, playing in a sandbox. Those who support. Some builders feel like they need permission to stop the work for any reason, even if it would be faster to stop and learn. So if you want to keep your builders from imagining that they mustn't stop and learn, you should expressly state that you support it. You can set the tone in your team by coaching them to take time to learn. And when they do, you can encourage them so that they know that it's good. And my experience is that this doesn't go without saying. Maybe it should, but it doesn't. And so if you're supporting builders, you can use your words to set the precedent that, yes, if you need to learn something before you can go do it, learn it, and approving when it happens. All right, that's that. Let's have fun and build well. Thanks so much for having me.
Cool. Hey, Alex, that was great. I appreciate, and the summary that I'm taking away from this is that what you were doing here is going in and saying, I don't understand how test frameworks work. I'm going to build one so I have a greater appreciation of what's going on behind the scenes to make this and why it might be valuable to me. Okay.
Yeah.
I did recently did something with that with trace instructions, like where you say, I want to see every time this method is called when it enters and exits. And it was very eye-opening to capabilities I was working with Common Lisp, but the language I was working with that I didn't understand how it did its magic. And now I understand just a little bit more of some of the magical
Yeah.
things that happen. And I can see how that would come from this too.
Yeah.
Let's see. Somebody asked a question a little bit in different vein, but I want to get to it too. He said, "You've rightly put on your website the key to success is to be customer focused. How did you overcome a software engineer's confirmation bias tendency while gathering and understanding customers' needs through implementation to avoid, I think, diverging from customers' expectations?"
How did you overcome software engineers' confirmation bias? Is the person who asked this willing to pop on and add some more words to explain it?
I think
Otherwise,
it's.
I'll read it again and see if I can parse it out. How did you overcome?
I think it's AB, and I think you're on. AB, do you want to come off mute and talk to Alex about what you're looking for?
So we got software engineers' confirmation bias tendency while gathering and understanding a customer's needs throughout implementation to avoid any deviation from the customer's expectation. So overcoming the software engineer's confirmation bias. So what I understand from this is we're talking about we're going to go figure out what a customer needs, but I've got an idea of what they need, and I'm biased towards hearing them say I need such and such, if it aligns with what I expect. And so the question, as I understand it, is how do we go about understanding the customer's needs without having our own preferences cloud our judgment? If I'm misunderstanding the question, please send a message in chat or something, but I'll respond to that question as I understood it. How do we deal with a confirmation bias when we're talking to customers? I think iteration is the trick, that you're gonna get it wrong. So put something in front of them and say, is this what you meant? And they go, no, that's useless. And then you just listen to what they say. So like the first attempt will not go well. And so if you can do a sketch the first time and they look at the sketch and go, ah, and then you do a better sketch and eventually you get a sketch and they go, yeah, okay. And then you build it and they go, oh no. And then you listen to whatever they say after, oh no. Or for us, we work more with product owners than directly with customers. And so it's, I couldn't release this. If I release this, all the customers are going to say, and then they tell me the next most important thing. And we go, okay, we'll build that. And they go, oh, I would release this, except there's this next missing thing. And so it's just putting it in front of them and then listening to their complaints. And that way it doesn't really matter what my bias is or what I'm expecting them to say because I'm just paying attention to what they say. So yeah, the first one is, it's going to be garbage anyway. I'll misunderstand, but once they start listening to that feedback and iterating, I found that that I can now tune it to more something sensible. And I guess disengaging the ego when they make their complaint. And my first reaction is, you don't know what you're talking about. And then I go, oh wait, they absolutely do. I don't know what I'm talking about. And then shifting.
Cool. Any other questions for Alex?